Our next unit is exponential functions and their inverses. So first, let's take a look at what an exponential function is. Y equals a times b to the x power. So an exponential function is when the exponent is a variable. A is the initial amount, b is the growth or the decay rate. And we're going to see this later in this video, but to find a growth rate, you take your percentage, turn it into a decimal, and add 1. The reason you add 1 is because you're keeping 100% of the amount that you have, and you're adding on, or it's growing. For a rate of decay, decay is the amount that you're losing. But when you put it into the equation, you have to use the amount that you're keeping. So you subtract the amount that you're losing from 1 to get the amount that you keep. X is the amount of time, and Y is the amount after time. We have a compound interest formula here. What this does is it tells you how much money you will earn on your investment. P is your investment, or the initial amount that you're investing into an account or putting into a bank. R is the rate, the interest rate that they're paying you. N is the number of times that the interest is compounded per year. What that means is, say you go to a bank and you open up a savings account and they give you typically 2 or 3% interest, not a whole lot, and they compound it quarterly, which means 4 times a year. So every 3 months they'll sit down and figure out how much interest they owe you on your money. That would be N. And then T is how long you're leaving it in the account. So we'll see that a little later as well. So first we're going to take a look at exponential functions. And the first thing we're going to do is just practice evaluating. So you substitute a value for x, punch it into your calculator. Fairly straightforward. So our first question is, what is f of 1? So we've got 25 times 3 to the first power. Exponents first, 3 to the first power is 3. 3 times 25 gives us 75. Evaluating at 4, we still do exponents first. 3 to the 4th power is 81. And 81 times 25 gives us 2025, or 2025. Example 2, same thing. We got a slightly different formula. This time we have x minus 1 as the exponent. So g of 1, 4 to the 1 minus 1, or 0 power, is 1. Anything to the 0 power is 1. We looked at those exponent rules earlier. G of 4, 4 to the 4 minus 1 power. 4 minus 1 is 3. 4 cubed is 64. Next thing we're going to take a look at is the graph of an exponential function. So the first thing we're going to do is make a little t-chart. So I like to do a couple of negative values, 0, and a couple of positive values. Substituting those in, 2 to the negative 2 power. Remember when we were simplifying negative exponents, it meant flip it or put it in the denominator. Sorry, lost my denominator there. So 1 over 2 squared, or 1/4. Same thing if we substitute negative 1 for x, the reciprocal 1 over 2 to the first power, or 1/2. 2 to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. And 2 cubed is 8. So we plot those values on our graph. So negative 2, 1/4 would be about here, except for my calibration's off, as usual. Negative 1, 1/2. See if we can get that a little more accurate. 0, 1. 1, 2. 2, 4. And 3, 8. So an exponential function, even though it doesn't quite look at it like it does have the x-axis as an asymptote. So remember, we talked about asymptotes when we did rational functions. It's a line the graph approaches but never crosses. You can never get 0 as a value, because no matter what, think about these negative exponents that we were substituting in. Even if I had negative 100 for x, it would be 1 over 2 to the positive 100th power. And even though that would be very, 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 very tiny, very close to 0, it will never equal 0.